All right, first things first, we are finishing up. This is 6-4. We're looking at the graphs of these beasts. We're already 4 sections into, yep. We're already 4 sections into this beast. So we're doing pretty well. Let's look at what these graphs look like. Oh, did I put them on my other screen? I did. That's not very helpful. So what do the graphs of a natural log look like? They look like this. Okay. So what I want you to notice about this is just something put in the back of your head. Each of the x is an exponential. Exponentials look like that, right? If I were to flip this over this line, it would look like this, right? Because natural log of x is the inverse of each of the x. They're inverses of each other. So they're mirror images of each other for the graph. Okay? You don't have to know that, but it helps me remember what the graph looks like of log, right? Log is just a flipped exponential function. All right? So one thing to keep note of when we look at this graph is the domain is from 0 to infinity, right? Because I can't get negatives by taking something to a power. So my domain is from 0 to infinity. My range is from negative infinity to positive. It looks like there's an asymptote, but it's going to keep going on forever. There is one asymptote, and that's going to come up, and that is right here, right? Because again, it can't cross that. We cannot get a negative out of a log function. All right? And if you really want to know why we can't, because if we have log base 10 of anything, it's saying, or let's say a negative anything, 10 to what power equals, that's a circle, equals negative 10, well, nothing. That's impossible. All right? Okay? Okay. There we go. If we understand that, you'd have to subtract it over to do it. Oh, then you'd be flipping it, or you know what I mean? You'd have a negative. No, that still doesn't work. You can't. Because if you plug in a negative to a log function, it always will say error. What? Okay. That's good talk. All right. I talked about it. All right. Shifts. Horizontal shifts are by H. Vertical shifts are your K. Have we ever seen that before? I think this is number 4 or 5. No. All right. Just remember, this is always opposite. That always is what it is. If it's in parentheses, too many crickets. You ever feel like news is just thrown at your face constantly all the time, no matter what you do? All right. That's for the best. I will say we're going to add one new thing to this. Earlier when we learned this, I just had you call it a stretch shrink. You didn't have to call it one or the other. Now we got to start calling it one or another. Okay? If the number's in front, it is a vertical because it's affecting the y. And I'll also say this. Remember, if a is bigger than 1, it is a stretch. And if a, I should have wrote that the other way. It's between 0 and 1, it is a shrink. I don't like the way I wrote that. That is what it is. If a is bigger than 1, it's a stretch. If it's between 0 and 1, it's a shrink. If it is 1, it's doing nothing. You don't worry about it. If it's negative, that flips it, so we don't worry about that for making it larger or smaller. Now, if a change is happening in parentheses, it is always opposite of what you think it should be, right? Because if I'm subtracting, I go to the right. Adding, I go to the left. So for this one, it's the opposite. If b is bigger than 1, it is actually a shrink or a compression. And if b is between 0, and 1, it is a stretch. Okay? It's actually by the reciprocal of it. We'll do an example of it. I always say, make sure you know anything that happens by the x is the opposite of what you think it should be. Okay? All right. If a is negative flipped across x, b is negative flipped across y. Okay? Honestly, you should probably, if you're using notes on things, especially for the final, this sort of thing should be like a really important, it comes up in every unit. We've done it in many different ways. Still tricky though. All right, let's do it. Bless you. All right. Okay, let's look at this beast. All right. Let's just go step by step in what each number means. Is that 2 in the parentheses or on the outside? Outside, and it's bigger than a 1. So that's going to stretch 2, right? It's a stretch by factor of 2. It's going to get taller. Oh, let's do this too. It's vertical. Vertical. Anything on the outside is vertical. Anything on the inside is horizontal. Your home inside. The plus 5, since it's in parentheses, you go the opposite way. So that's going to be left 5. Yeah, it's horizontal if it's by the x. Shift of left 5. And the minus 9 is going to move it down 9. Vertical. It's a vertical shift. I think a lot of you guys could have probably figured that one out without the lesson, but that's okay. We're adding this, so we need to know if it's a stretch or a shrink on the outside. All right, natural log. The 2 is on the inside. If the inside, it's horizontal. Now, is it going to be a stretch or a shrink? That one's going to be a shrink, actually. It's going to be a shrink. Shrink by 2. That means I'm dividing everything by 2. I could have also called it a shrink of by a factor of a half because you're multiplying by a half, but you can call it horizontal shrink by 2. Will work. And the plus 4 will move us up 4. So I could fake my way through this graph. Yar nar. Okay. All right, same functions. Let's find the asymptotes. So I'm going to reference this piece over here. Our normal function of all my logs, natural or unnatural, looks like this, and it has an asymptote at x equals 0, right? That's the only asymptote. Now here's my question. If I move the graph up or down, am I changing that dotted line? No. If I'm stretching or shrinking it, am I moving that dotted line? So the only thing that's going to affect that asymptote is shifting it left or right. So if my normal asymptote is x equals 0, what's this plus 5 going to do to it? It moves it left 5. The other way you could think about it is, so I do it that way. I'm saying it's going left 5. If I go left 5 with 0, that's negative 5. The other way you can actually do it is you take this, you can think about when is that going to be equal to 0 and solve it. That's going to be equal to 0 at negative 5. Yes or no? Don't overthink that. Now this one, am I doing anything to the x, shifting it left or right? No. So is my asymptote going to move? No. It's just going to be x equals 0. Right? Doesn't matter how much I move it up or down. Now, if you have your graphing calculator, can you always graph this and just kind of see what's happening? I would. You could. But you don't, like I said, if there's not a horizontal shift, your asymptote will be x equals 0. All right. One last thing, and I'll have my watch. Have you guys ever heard this before? Have you ever been looking for the x-intercept? And you set y equals 0? And have you ever been looking for the y-intercept? And then you set x equals 0? You think that's going to come up on the final? All right. This is going to be a little bit, not the setting it up is going to be easy. The solving it's going to be really tricky. So let's do it. If you get really in a pinch, I will say this is one that graphing it and kind of trying to find your x, y intercept, like using trace or something, it's not terrible, but you won't get the exact answer because it's good. They're always going to be decimals. So let's look at this piece. I'm going to write over here. It's less shiny. Let's do the y-intercept. That's more straight. Y-intercept. What am I doing? X equals 0. So let's do it. So I'm going to say y equals log base 4 of 0 plus 3. Just don't do it. All right, let's do this. So y equals log base 4 of 0 plus 3 minus 4. No, I need to finish this. Well, that was rude. All right, so I get y equals log base 4 of 3 minus 4. So I get the point 0, this. Now on your homework, because we do not have the ability to calculate that yet, you're going to have to type it out the long ways. All right? Because you cannot get that as a decimal yet. We will be learning that later. Because that's not log base 10. But that is good to know. That if that base isn't 10, you just cannot plug it into your calculator. All right? This is important. All right. So we get that point for our y-intercept. Our x-intercept we can solve, and you do need to know how to solve these logarithms. Just like you need to solve everything. All right. So for the x-intercept, we set y equal to 0, right? So I set the equation equal to 0. And I solve for x, correct? It's her. All right, so we set y equals 0, and we solve for x. So solving equations, onion method, what's the furthest thing away from my x? The 4, right? The 4. We're going to put the algebra back into college algebra right now. Now, what is my rule? What do I do with that base? Back a long time ago, we were doing like log base b, of y equals x. What does that actually mean? B to the x equals y, right? So I do 4 to the 4 equals x plus 3. Okay? 4 to the 4th is x plus 3. 4 to the 4th is 256. And then I subtracted 3 from both sides. So the new thing, the brand spanking new thing we got, is remembering that when I have a log, I can take the base to the power of what it's equal to, It'll be equal to what's in our parentheses. It's honestly the math that, like, when you look at this, it looks very complex. It's very easy to get overwhelmed by it. I get that. But when you think about it, there is not a single piece of math here that you have not done at some point in your life. You know what I mean? 4 to the 4th power. But that looks incredibly scary. You know what I mean? Believe in yourself like I believe in you. All right, one more example, and then we're done for the day. Wait, I think. Hold on, let me make sure. Yeah, one more. All right, let's find the x and y intercept of this beast, the natural log. We're going to do the same process. For y-intercept, plug in 0 for x. So I do y equals natural log of 0 minus 2 plus 22. Again, can I, actually this one we can do. This one we can do. Can we? Grab out your calculators. You have a natural log button, right? What's natural, what? That, oh, where did I get 22.2? You're right. View. What's natural log of negative 2? Try it out for me. See what happens. What? 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 It's there. No y-intercept. Can we have functions that don't have a y-intercept on this beast? Yeah, we can, right? Because the natural function looks like this. It doesn't even have a y-intercept. Can I take natural log of a negative? No. But why I want you to realize this, if that was natural log of a positive, we could do it, right? But good thing is when I go do a log, if I get a negative, I plug it in. I'm not thinking I get an error. It means there isn't a y-intercept. There has to be an x-intercept. There will be one. There does not have to be a y-intercept. Okay? So for x-intercept, I'm going to do 0 equals natural log of x minus 2. All right? Again, this looks very intimidating. I assure you there's only one step different than what my Math 8 kids are doing right now. There's one new step. So just let's make sure we pay attention. What's the new step going to be? I'm going to subtract my 22. Yep, I'm going to subtract my 2.2. Maybe I can't do this. What's my base in natural log? Or how can I cancel a natural log? My base is a e. So I can do e to this power, e to the negative 2.2 equals x minus 2. Right? Now I'm going to tell you two. So, now I'm going to add my 2 to both sides. I had to check. So I get e to the negative 2.2 plus 2 equals my x. Now, you can plug that in your calculator, and that's what we're going to want to do for your homeworks because we're going to want decimals because that's hard to plug in. If you go upwards in calc, you're going to leave it like that because there's no rounding in that one, right? What did you guys get when you plugged in? 2.11? Yep, that sounds about right because that'll be a very small number. So we get the point 2.110. So again, what is the new step we have on all these problems from the last week, actually? The using the base to the equals, set equal that. Okay, if you can do that, you're going to be in really good shape for this unit. That's it.